Okay, in example 2, I'm just going to graph one period. It says to graph at least one, so 1 would qualify there. And so here we go. We've got cosecant of x plus pi over 4, and so because this is a cosecant function, I know I'm going to have to find all of the information for a sine graph. And so that would start with the amplitude, which is 1, since the lead coefficient is a 1, and the vertical shift, which is 0, since there is no plus or minus a constant at the end. The next would be the period, and so that's going to be 2 pi divided by b, which in this case is 1, and so that will just reduce to 2 pi. That makes the x increment then, period divided by 4, which will reduce to 1 pi over 2. And then finally the phase shift, and I notice here that the b is factored out since it's a 1, and so that tells me that the phase shift is negative pi divided by 4. And so negative pi over 4 is going to be right over here. That's going to be my starting x value. My next x value is going to be my starting point plus my phase shift, which is going to have to be altered if I want to be able to add to those fractions. And so I'm going to have to multiply this by 2 and the denominator also by 2. And so negative 1 pi plus 2 pi is going to end up giving me 1 pi divided by 4. And so I'm going to actually skip over 0. That's not going to be one of my 5 points here, which is a little confusing in the beginning. It doesn't always have to be a point, and it's certainly not here on this example. So now add the x increment again, which is pi over 2, but really and truly, it's probably easier at this point to, instead of write pi over 2, just go ahead and write 2 pi over 4. And so that's going to give you 3 pi over 4. That will be the next x value. Next will be plus another 2 pi over 4, which is going to give you 5 pi over 4. And so that will be my fourth x value on this graph. And then the last one is going to be 7 pi over 4, since I would just add another 2 pi over 4 or pi over 2. Okay, so on my y-axis, I know that y equals 0 is going to be my midline. I've got an amplitude of 1, so that's going to be 1 and negative 1 there. And so at negative pi over 4, I'm going to start graphing here with a 0, since this is a sine function, and sine functions start at 0. At pi over 4, I'm going to be at a max. Notice that I did not graph any sort of point here on 0, because it is not one of my 5 points in this particular problem. At 3 pi over 4, we've got a 0. At 5 pi over 4, a min. And then at 7 pi over 4, a 0. And now, if you want to sketch graph the sine function, you certainly can. I don't necessarily always do that, but sometimes it is helpful. And so now at all of the zeros, we're going to draw vertical asymptotes. So negative pi over 4, 3 pi over 4, and 7 pi over 4. And then in red, I'll actually draw this cosecant graph itself. We're going to have a so-called parabola that goes here, and then another one that opens down here. And so the red part, again, is the only actual part of this cosecant graph. Okay, here on example B, we've got y equals the secant of x minus 3. And so the fact that this is a secant tells me that I need to find the information for a cosine graph. And so the amplitude is going to equal to 1, and the vertical shift is going to equal to 0. And so 0 is going to be my midline. An amplitude of 1 means that my y values will be at 1 and negative 1. Okay, from there, we're ready to start finding our period. And notice that b here is just 1, and so my period is going to be 2 pi. That's going to make the x increment 2 pi divided by 4, which of course will reduce to pi divided by 2. And then finally the phase shift, notice that b is already factored out, and so therefore the phase shift is going to be positive pi over 3. And so I'm going to put positive pi over 3 down here on the x-axis as my first x value, and then start finding my other x values by adding the x increment. And so pi over 3 plus pi over 2. Now this cannot be done because they don't have the same denominator, and so I've got to get them to be the same denominator, which of course would be 6. And so that means I need to multiply this by 2 over 2 and multiply this by 3 over 3. And so what that's going to give me then is 2 pi plus 3 pi, which will be 5 pi over 6. And so now what I want to do, just to make things easier, is think about my x increment in terms of sixths, which would be 3/6. That's what I'm going to be adding each time I get my next x value. And so 5 pi over 6 will go right here. The next one, if I add another 3 pi over 6, this is going to equal to 8 pi over 6. Now when I write that on my graph, I'm going to do it simplified. And so 8 over 6 just becomes 4/3. I'm then going to add another x increment, so another 3 pi over 6. That's going to give me 11 pi over 6. And then, so that will be my fourth x value. And then finally, I need one more, which means I'm going to add one more 3 over 6, which will give me 14 over 6. And reduced, that will be 7 pi divided by 3. Let me erase that 6 because it should be a 3 down there in the denominator. There we go. And so there's my 5 x-axis points. I remember that I'm doing a cosine function, and so that means that we will start at a max, go to a 0, then to a min, then to a 0, and then to a max at every 0. So that would be 5 pi over 6 and 11 pi over 6. I'm going to have a vertical asymptote. So a vertical asymptote here and a vertical asymptote here. And then at every maximum and minimum, we are going to put our so-called parabolas. And so a little half parabola that goes back to the right at pi over 3. At 4 pi over 3, we'll have a full downward opening parabola. And at 7 pi over 3, another half parabola that opens up and to the left. Okay, here in example C, y equals 2 cosecant x plus 1. And so because this is a cosecant graph, I know that I need to find the information for a sine graph. And so that means we would start with the amplitude, which is 2, and the vertical shift, which in this case we do have one, it's 1 because of the plus 1 down here at the end. And so that means that on my y-axis, my midline is going to be here at 1, and my amplitude being 2 means that my maximums need to be up at 3 so that that amplitude is equal to 2, and my minimums are going to have to be at -1. Okay, next thing would be the period. This is going to be pretty straightforward. It's just 2 pi since b is 1, and that's going to make the x increment. At this point, you should probably be a master of dividing 2 pi by 4 and getting pi over 2. And then the phase shift, since there's nothing else inside the parentheses with the x, will be 0. And so that means on the x-axis, 0 is going to be my first value. Now, using the x increment to get to the next number, that would be pi over 2. Adding another pi over 2 would give me 2 pi over 2, which will reduce to pi. And then 3 pi over 2, and then finally 4 pi over 2, which again reduces to 2 pi. Okay, so now remember back, we are graphing a sine function and then just doing the cosecant parts of that. So at 0, I'm going to start at my midline, which is 1, and then up to a maximum at 3, back to the midline at 1, down to a minimum at -1, and then back up to the midline at 2 pi. And so at every midline point, 0 pi and 2 pi, I'm going to have a vertical asymptote. All right, and then at every maximum and minimum, we are going to have our actual cosecant graph. And so this is going to be a full upward opening piece of the graph here, and then a full downward opening piece of the graph there at 3 pi over 2.